Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the Project and Event Manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat. But before we begin, I'd like to quickly review two items, our Code of Conduct and Event Guidelines. First, please take a moment to review our Code of Conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link for our channel in the chat a little later. And if you've not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to access and interact in the chat. You can set that up now. And if you're unable to use the chat but have questions, feel free to reach out to us through social media or on Meetup. Which brings us to today's session. I'm going to bring in our speaker here, Bruno. Hi, Bruno. How are you today?
Hey, Alexia. Hello, everyone. Hey, I'm fine. Looking forward for the second part of the series.
Love it. Great. We're on to a great week today for JulyOT. Second episode. Super excited. Take it away.
Perfect. So let me share my screen and we can start. So hello, everyone. My name is Bruno Capuano. I'm the Regional Cloud Advocate for the Microsoft Toronto Reactor. I'm super happy to be here, really super happy to be here because we are doing kind of the second part of what we started on Monday. But before I start, let me talk a little about myself. I'm in my office wearing a black t-shirt of a Microsoft Reactor. I'm a white Latin person in my 40s, and I'm super happy because I see a couple of familiar faces. Hey, Kamel. Hey, Ravi. Super nice to see you here. And hey, let's start. Today I have a lot of stuff to show. Let's try to figure out if we are going to make it. Let's see if we can do it. So first of all, today I'm going to talk about how we can do machine learning, how we can create a module that is going to do computer vision, but you can create a module to do anomaly detection, regression, classification, whatever you want to do, and create this machine learning model embedded into a module that is going to be an Azure IoT Edge module, and then deploy it to an Azure IoT device. For this device today, I'm going to use the ReTerminal. ReTerminal is a super cool device from SeeedStudio, which is a kind of a Raspberry Pi on steroids. So we can pick up everything that we talk on Monday and use it today. And I'm going to show everything in this. So today is mostly a review of what we did quickly on Monday with Raspberry Pi and SeeedStudio, with Azure IoT Hub and the devices, and then how we can build and deploy models for this, and using the ReTerminal. So again, no slide today. I'm going to do this very, very, very fast. I see a couple of other people saying hi. Hey, Peter. I am going to say Peter. Sorry if I am saying your name in the wrong way. And going back to the slide, sorry for the demos. They are not the best demos, but it's mostly to try to learn together how we can do this. So that's it. That is what I have, my 2 minutes of slides. So let's start to talk what we want to do today. So let me start, and I'm going to play a 1 minute video. Probably not going to play the full video, but about the ReTerminal. So. Okay, so the ReTerminal is, as I said, is an amazing device. It's based on the Raspberry Pi Compute 4, which is basically, we have the core of the Raspberry Pi inside the ReTerminal, but out of the box, we have plenty of features, a couple of buttons, a super cool LCD screen. Then we have also a couple of sensors like an accelerometer. Then we have interfaces with an Ethernet cable and something else. So it's a super cool device. That said, I am still going to probably show and talk a little about the Raspberry Pi. Remember on Monday, we reviewed how we can register the Raspberry Pi as an Azure IoT Edge product. So if I go back to my hub here, this is my Azure IoT. Let me go to my IoT hub, and I am going to check my devices. I already did the step-by-step that we see on Monday to have my ReTerminal here. So what you see here, my ReTerminal 01 is my ReTerminal. I added the 01. I only have one, but I have the I don't know. I have the hope that in the future I may have another one. So this is my device right now. And hey, it's super cool. I don't have it here because it's in the back. I am going to show you right now. It's already connected to tons of cables, so I cannot show you. But this is super, super cool device. But it's like a Raspberry Pi. So I can go open a terminal. Let me make the font a little bigger. And I can do a ping to see if it's online. I hope it's online. Ping ReTerminal 01. Yes, there it is. So I can SSH the device. SSH p at ReT01. I'm going to ask my user and password. I'm going to ask my password. So here I am in the device. And this is what we saw on Monday. So let's clear this. If I do sudo IoT Edge list, I will see that I have my two modules up and running. Edge Agent and Edge Graph. This is basically where we leave the stuff on Monday. We did a couple more things, but yes. Hey, Peter asked a question here about, is there a video recording from Monday? I miss it, unfortunately. I am not going to say that word in English. I am speaking fast today. Yes, and you give me an amazing topic to also talk about JulyOT. We are doing this session because we are in July, and in July we get together with a lot of amazing people, plus myself, to talk about IoT and everything that you want to know, the recordings and everything else. You need to, if you navigate to JulyOT.dev, you see the URL there, you are going to see everything that we have here. So we have, in example, if you want to learn more, one amazing way to do this is join our Cloud Skill Challenge, which is basically a guided tutorial for a different learning path in the Microsoft Learn, where you are going to learn about Azure IoT. Then you have live streams. There is a full collection of live streams where we have, there it is, where we have Jim, myself, Maria, and I am not going to say all of the names because I'm going to forget people, but you have all of the IoT for beginners, IoT and DS. You can see the recording here. As Alicia mentioned, the recordings are basically 24, 48 hours later, so they should be in the Reactor channel. So everything is going to be here. And hey, you even have, if you want some swag, you have access to the meetups and events, the resources. Everything is here. And hey, by the way, if you speak Spanish, we are also running this in Spanish one day later, and it's not JulyOT, it's JulyOT. It's funnier also for me, but hey, we are also doing these sessions in Spanish if you want. So recording and everything, please navigate to JulyOT.dev and you can check this. Going back to the ReTerminal, going back to this. So I have a ReTerminal, which is basically a Raspberry Pi, as I mentioned. You have here the specifications, and I am going to ask Alexia if you are. Nangu say, hey Nangu, pleasure to have you here. I am going to ask Alexia if you can share this link so that people can access to the ReTerminal. And I also see that Alexia also was super cool and fast, and you share the link to the Monday session. So there it is. You can check how we did this. So let's hide the JulyOT dev banner. Let's hide these comments and going back here. So I like this device, as I said. It has plenty of stuff. It's not more powerful than Raspberry Pi. It's literally Raspberry Pi, but we have plenty of things on top. So I can SSH the device, as I show here. I can even do file system, so I can do src. I have here some tests and other stuff, so I do a tree, boom, we have plenty of files here. This is amazing, but hey, this is kind of a mini computer. So what I can also do, I can BNC this device. So I have this, I have the ReTerminal connected in the back. I am going to show you, and this is what you see here. This is my ReTerminal, and my ReTerminal is also connected to my TV on the back. So when I open here a screen, you're going to see this on the back. But let's make this a little more interesting, and let's show a camera. So this is a camera that I have here in my lab's decks. It's a mess. I'm sorry about that. I have plenty. Oh, it's turned off. Let me turn it on. So let me turn it on. Let's close this one, start again. So this is a camera that I have in my lab decks in the back, and you can see there in the camera that I have. This is the ReTerminal that I have running, and it has connected the power, the TV, and also a USB camera. This is the camera, and the camera is pointing to a couple of animals. The idea of today is to show how we can show the camera, use the camera, show the camera, and do a computer vision analysis on real time. So this is the camera, this is the ReTerminal. If I get here, you see that I have a mess here, but hey, you got an idea of what I have. And as I said, this is literally a PC running a Raspberry Pi OS. So I can do plenty of stuff here. I have here open my my command lines, and hey, I can even go to src, ls, can't remember where, 01, cam labs. I have here a couple of files that I can open, so I can do Python 301. This is going to open the camera in the ReTerminal. So what I am going to see now is the USB camera that I have in the ReTerminal. You can take a look. The view in the screen, the small view that we have here, this is what I see in the device really in the back. This is my remote, but this is the camera in real time, the USB. So if I go here and do this, you're going to see my hand there in real time, and I can start to play around. I have everything connected to do this. That's why I didn't bring the device here, because it's super nice, but moving the device with all of the cables is kind of a mess. So this simple file, it's basically picking up the local camera and showing the camera. And one cool way that we can develop, and I didn't show this on Monday, we didn't do a lot of code, but if you want to develop against your Raspberry Pi, there are a couple of ways that you can do this. I really like, let me close Visual Studio and open a new one, Visual Studio Code. I really like use a remote server. So basically what I am going to do now, I am going to remotely connect to the Raspberry Pi. So I have an extension. Let me cancel this one here, close remote. I have this extension, there it is. I have extension, which is Remote Explorer, that you can install. And when you start Remote Explorer, you can basically add new devices. And when you add a new device, you can connect the device here. So I'm going to connect to my ReTerminal, right-click, connect. And this is going to open an SSH server. It's going to ask me for my user and password. And hey, once I am there, I am in the remote server. I can open a folder. I am going to see here the full folder structure of my device. And then, hey, I am going to do the kind of the root of the SRC. And this is all the files that I have here in my ReTerminal. And how, last time that I talked about this, someone asked me if I need to install something new on the device, if I need to do something else. No, this is going, Visual Studio Code is going to automatically install everything for you there. So in example, if I go here, I just run this file. Let's close this one. This is the file that I run here. Let's zoom in, is Shift Control Plus. plus, so it's not doing the shift control plus. Let's do a zoom in again. So I just run this file, the O1. If I change something in the O1, so an example, let's change the title here. Let's do Reactor JulyOT and run again the file, save it and run again the file. We are going to see that the title that we have here in the camera viewer is the one that we have there. So we can see here, super small, sorry about that. Let me zoom this, but hey, this is Reactor JulyOT, which is kind of nice. So there are a couple of ways that you can do this. If someone wants to know how you can set up your remote development environments against your Raspberry Pi, let me know and I will show you. It's just 5 minutes. I have a Raspberry Pi here, so I can show you very fast. Otherwise, I move on. So what I want to do today, I want to basically use the camera that we have here. And sorry, I minimize this. Let's open the camera again. I want to use the camera and I want to train a model that is going to identify squirrels or this space marine. So this is my goal for today, train a model for do this. There are plenty of ways that we can do this. If you are a machine learning expert, if you're a computer vision expert, you probably pick up PyTorch or TensorFlow and train your model. I will go in a different direction. I will use one of the cognitive services, service that we have, and I'm going to use this one, customvision.ea. Customvision.ea is, as I said, it's a service, part of the Azure Cognitive Services, but it's kind of a super amazing service to create your own machine learning computer vision models. Because let's train a super fast model here. So the way that this service works is you need to upload and tag your images. You need to ask Custom Vision to train the model, and when you have your model trained, you can use your model in different ways. You can basically ask for an endpoint on the cloud where you can post your images and get your image analyzed. You can export this image as a TensorFlow model, as a Nonix model, and other formats to be used in different platforms. Or you can even export the trained model in a Docker file, which is going to, the one that we are going to use today, and run this in different environments. So let's create a new one so you can take a look. So let's go drawings, JulyOT. There are different type of models that I can do. I can do classification, which is basically I'm going to have an image and I'm going to have a main label of the image. This is a cat or this is a dog. I can do object detection, where I will train the model. When I submit an image, it's going to say, hey, I find a cat in this position and a dog in this position. For us, what is important here is classification. This is going to be very simple. And then they have some kind of domains here that I can use with pre-trained models. If we want to do something for food or landmarks or even retails, we have these written models. I am going to go classification and general, and that's it. I will create the model. Once I have created my model, the next step is to add images. So I am going to literally upload images. Let me go for my machine learning resources. This should be in my disk C, not in Linux. This is in Windows. Where is simple drawings? So I am going to upload these simple drawings of fishes. And I have fish. I am going to define a tag here. I can add my own tag. So I am going to upload this 14 file of fish. Then I will upload a couple more for little humans and flowers. So I have flowers. And by the way, I am doing this. I can upload more images to a pre-created label that I have, or a negative one. I am going to do this in a very simple way with human, fishes, and flowers. And I am doing this because mostly, oh, I think I upload everything into, oh my God. Sorry about that. That's a mistake. So I upload all of the flowers into fish. Let me tag this one. This is not fish. This is flower. And this is also super cool features that we have here. We can easily change, add, and change label here. So I am going to add the last one, which is going to be human. And let's do this little person, humans here. I have drawings. And I am doing drawings because I really like, it's kind of fast to train a model when it's just black and white, simple drawings like this. So, hey, I have this. What I need to do now is I need to train my model. So I'm going to quickly train my model. This will, there are different options here. I went for the fast one. You have a quick training, or if you want to use your Azure credit, you can go for a more specific one, put some serious resources here to train your model. There's also some limitations here where I can't really remember. Hey, Nevin, pleasure to have you here. I can't remember, but there are some limitations about you can only have 5,000 images, I think, and I can't remember how many tags. So there are a couple of things that you need to know when you do this, but hey, you can even try this for free. And what I really like is, as I just mentioned, that once you train your model, and I'm going to give this a couple more seconds, you can test it and you can use it. So let's test it. I am going to open Paint. I am not a good artist, and I am even worse with my mouse, but hey, let's do an angry fish, and let's do JulyOT. So I am going to save this probably in my desktop. So yes, let's do fishy, and let's do a new one, and let's do here a flower. Sorry again for my crappy devices, my crappy OT. Let's do flower, and let's do I don't know, hashtag, add, and a smiley face, kind of a nothing here. Why do I create the third one? I want to show you what's happened when you have a non-tagged image. So I have the three. This is still training, as I said, because I am using the free version here. It will take between 30 seconds to 5 or 10 minutes. Let me go to a model that I already have trained, and let me show you how this works. So I have already created this one. This was created, I can't remember when, a couple of months ago. I trained in this. It's using the same images that you can see here. I have a couple more for testing. But hey, I can start to test my model. The model is trained, so I can browse local files. Let's go for the desktop. And let's pick up the fish. And once I submit the file, I will have this analysis out of the box from Custom Vision. So it's analyzed the files, and it's realized that, hey, I have analyzed the file, and the models, it's sure in 84.2% that this is a fish, and very low scores, 7.9 and 7.8 for human and flower. If we submit the other files, I submit the flower, an example, this is going to be analyzed again, and hey, this one has 83% of a flower and different values for fish and human. And hey, if we add a drawing without nothing, what we are going to see is that it still do the analysis. And hey, somehow in this drawing, it detected that this is a human with an 88.8% of probability. So hey, we need to fix our model here. So this is the moment that we can go back, go to the predictions, which is basically the one that I just add, and say, hey, flower, I am going to say that this is a flower, save and close. This one that I upload is going to be a fish, save and close. And this one, I should probably add this model to the negative one, because this is nothing. So I can do save and close, and once I have this, I can start to train again the model. I'm going to have probably an error here, because I need to have at least 2 tags and 5 images, and I only have 1 negative image, so I need to add at least 5 negative images. But you get the idea. Once we start to train these models, this is the output that we are going to have. So we are going to have, I trained this model a couple of times, so every time that I train the model, I have kind of a machine learning metrics here with the accuracy, the precision, the recalling the IP from the model, and you can see how these values were changing from the first one, which wasn't very good, to the second, and to the fourth iteration, which is kind of better. And I can do a couple of things. I can publish this. I can say, okay, let's publish this model on the cloud. I am going to use my resource. And once it's published, I will have a URL I have here my URL that I can use to to use this model. So I can do an HTTP post to this URL, and I am going to have a result, a JSON file, where we are going to have, this is a human, this is a fish, or this is a flower. And this is cool. We can use this. I'm going to unpublish this. But I really like that here, I can also export the model that I just trained. And as I said, it could be to TensorFlow, to Onyx, or even to Docker. So how many of you, if you let me know if you know Docker, you're going to probably know 85% of what I'm going to do next. So please let me know in the comment if you know how Docker works. But hey, this is cool. I will export the custom vision trained model. And remember, we train this without doing any coding. We train this using just our images. I am going to choose here to use a Linux version of Docker. I even have a Docker version for IRM, for devices like Raspberry Pi, which is super cool. Let's go for Linux, for IRM. And I'm going to export this. I am going to download this and let me show how it works. So I have here Ravi saying that Ravi knows Docker, which is super cool and super nice. And hey, if you have this model already, let's download this. Where is this? There it is. Save. If you have this model in your local machine, this is what we are going to have. So let me open an Explorer and move it here. And where is my model? This is my model. So this is the zip file of the exported that I have just downloaded. And if I extract this here and I open this with code, this is what, sorry about that. This is what I am going to have exported from the cloud. So I'm going to have a Docker file. Again, nothing important, nothing big. In this scenario, let me do the font a little. Hey, Nangu says that thank you for this session, incredibly useful, really helped me with AC 2020. Oh, thanks a lot. Thanks a lot. And hey, you can watch the recordings. Thanks for being here. I really, really like it. So thanks a lot. And as I said, so this Docker file, the one that we export, is basically, let's go rapid, is going to use a small Linux base for devices in ARM, like the Raspberry Pi. It's going to install a couple of libraries to do machine learning, and then it's going to run a Python application. If we take a look at the Python application is a web application that is going to use Flask to create a web application, and it's going to have two main endpoints, web/image and web/URL, where in image we can post an image embedded in the post, and it's going to use the model that we have here to do a prediction. So it's going to say this is a flower, or this is a human, or this is a flower, human, or fish. I can remember, and it's use everything else. So what I did here in order to use this, because we already have this and we can run and use this is super fun. I decided, okay, so you know what? I can go here. Let me switch to another, to Reactor. I can run this project. I can run the app that I have here. I probably need to switch and change a couple of paths. Let's see if it works. But if this is working, I can post an image here, and it's going to give me a JSON result to see if this is let's see if it's able to run the image. Okay, I don't have the configured, I don't have the right configuration for my NVIDIA and my graphic cards. Ignore this. This is Windows 11 being Windows 11. And hey, yes, I know that I should change this copy path, and let's do this. So let me create a new terminal, and let's run this Reactor, and let's run the app from here. So this is basically running the website app that I have from the exported from the model on the cloud. And this is a web application that is going to have 2 endpoints. I have here my URL image, and hey, I can test this. I can give it a try. So if I copy this, and let's do this like this, and let's do this like this, I can came back here and use standard client, and I will create a new request, a post request. Remember, we are sending images to this file. I'm sending a post, and in the body, I am going to send the binary file. Let's choose from my desktop. Let's choose the fishy. So I'm going to make a post, send the fishy. We are going to see here invalid URL. This is local, so let's do 1.701. Let's see if it's no. So it's just in case, let me change the port to see where are we using this. So app, it's using the port 80. Let's start this in 8080. I may have using the port for something else, and it should be fine. So let's run this again. So again, what I am doing, I am running the exported model locally, 8080, and it should be working. 8080. Oh, it's image. Sorry, that's on me. It's not post, it's image. My endpoint is image, so I'm going to send this invalid URL. Let me copy this just in case. Image, still invalid URL. Should be working right now. 8080. This is local. Not sure why it's not working, but hey, the idea is that I can send this. I'm still in local. What I have here, my local files. Yes, I supposed to be. So Naveen is asking a question about in the MQTT panel, what do you use? I didn't make any configuration for the MQTT. It's all managed by Azure IoT. You are going to see this when we start to work, but I don't have any MQTT panel here. Maybe if you can share more details of what you want to do, because I am not using one of these here. So hey, I'm sorry, I'm not sure why this is not working. Let me give this a last try. Basically, let's change this to use 1.7.0.0.1 port 8080. Let's run it again. And in the new request, I am going to change this for 8080. So it's running locally. I'm going to make a post and choose a file. Have fishy, binary, headers. And somehow my URL is not happy with my URL. Don't know why. Let's create a new one just in case. No, this one. Thunder client, new request. Copy this. And hey, by the way, if I test this in the browser, I should have, yes, so the URL is fine. So it's 8080. This is the code that I have here in my default here, custom vision AI model host kernel, and it should be /image. So this one, post/image, if I go to the body and I send a binary file like the fish, I don't know. I don't know why it's not liking. Let's do this, send invalid URL. So somehow, oh, I have a space on the front. Oh my God. So sorry about that. This is, if you add a space, just to let you know what was happening. I have a space here on the front, and hey, it didn't like the space. So just a suggestion for the Thunder client people, trim this. So, hey, I am analyzing the image. I have my results here. And as you can see in the bottom, I have here a fish, which is 93% sure that this is a fish, and I should get 2% sure that this is a flower, which makes sense. This is what we want to do. So the idea here is that once I have this up and running, once I have this application, I can quickly create a new function, a new Azure IoT module, and embed this code. So I can go here, Azure IoT Edge. If you have installed the Azure IoT Edge, I can create a new IoT Edge solution. So it's going to ask me where. Let's select these folders. Let's do IoT. So let's create this folder. And it's going to create a new solution. Let's do Python, and let's do image drawings module, the Docker repository. I'm going to do image drawing module, and it's going to create a new module that I can deploy to Azure IoT to be used for modules. And what I have here is basically in my module, I will have, let's close this. I will have a Python file that is going to create a client. Let's maximize this. It's going to create a client, and what the client created is going to run a terminal loop to see if we have message. This is full code that we have for this. So in order to make this work, what I have here, what I have created is literally I have created an Azure IoT solution. Let me see, this is the squirrels. So this is the image drawing. So let me open this one. So I have created, and while we are loading this, so this is an Azure IoT solution where I pick the original Docker exported module that I have here, and I embedded this one here. So this is going to create an Azure IoT module, Azure IoT Edge module, that is going to register itself when it starts. Let's do the code from bottom to back. No, I have another one. So this is going to run initially the Azure IoT the Azure IoT module. So it's connected to Azure IoT, and also run a web app, which is going to do the custom vision part. So the Azure IoT module, let's go here, is going to register the module into the device that we are running. It's going to get for message, it's going to wait for message. And then in the web part, we are going to have a host in the port 8089, and we are going to have literally kind of a copy and paste from the previous one, where we are going to have an image endpoint and also a URL endpoint. I see your question here, how to connect the application in mobile with the computer. Let's talk about this later. Naveen, I'm not sure what is the goal that you want to achieve. But this is a module, so I can go here and build my module. So let's do something. I already have my module here, and right now let's go to the module here. I'm running the version 57. Let's go version 60, and the schema, let's leave it like this. So I'm going to build my module. And a couple of important things here. Because I am running this with an ARM module, an ARM CPU, I cannot build this on my machine. So I am using another Raspberry Pi as the build machine. So if I take a look here in my configuration, in VS Code, here, when I define who is going to build this, I have this machine, rpdev06, which is the one building this. By the way, if you want to learn more about this, I write Bruno, use Raspberry Pi as, I write build Docker images, this one. I am going to ask Alexia to share this link. Oh, this is not my blog. This is someone else's blog. And I see that some people copy my, okay, no problem. This is my blog. This is what's happened when you publish for free. Some people copy your code. So I create a tutorial step by step So how you can build this and how you can use a Raspberry Pi to share your model, to build your Docker images. So right now, my image should be done, should be built. It's already built on my Raspberry Pi. So what I need to do, I need to publish this. And in order to publish, I am going to use, remember that last time I talked and I showed how I have a repository, an Azure Container Registry, with my with my images. So I have an Azure Container Registry here with images that the repositories that I create. So somewhere here, I have the image drawing recognition module, and the latest version here is 57. So if I go back to Visual Studio and build and push, I am going to push the version 60. This is going to build the module, and once it's built, it's going to upload this to the cloud. And the cool things about this is that now I can go, while it's publishing, I can go to my device, I can go here to my ReTerminal, and I can add this module there. So I can get here in the ReTerminal, and I can add the module there. So let's copy the information. Let's add it here. So this is IoT, and the password here, and I'm going to add a new module. This is going to be the image Jury, which is going to be the one that we have. Let's do these drawings, and I have a couple of environment variables here, which is basically or true, and in container create options, I am going to open this and use port 8089. So I am adding this as a module to my ReTerminal, the one that I just export. So let's do create. And if I go back to my ReTerminal here and clear, I do the list, I will see these two. And after a couple of seconds, I will see the third one, which is basically the image recognition module. In the meantime, Visual Studio should already publish this. So I should get in my container registry. If I refresh this, I will have the new one, the 60 that I just published. So this is kind of the step-by-step of what we can do to publish these modules, to export from the computer vision, to create the Docker version, to create our own function. By the way, I write the step-by-step, how you do this, so you can take a look and see this. But the idea is that, hey, what else I can do? I want to recognize the squirrels and the space marine. Remember that still here I have these two guys. So I created a custom vision project that is here on the top, a custom vision project that have tons of images, and this is not doing kind of a classification. This is, I draw a box near each one of the objects, and I say, this is squirrel, this is space wolf. If I start to take a look at the other images, squirrel, space box, squirrel, space box. So I train the model using tons of images, vertical images, horizontal images with only one object or two. And I export this. I did the same process, and I have this already in my container registry. So if I take a look at the repositories, I have one which is the squirrel object detection module, this one here. So I can add this also to my ReTerminal. So here in my ReTerminal, I should have the drawings module up and running. It's not running yet. It's probably working. So let's add the squirrel object detection. So this one, let's add a new module, URI, let's go squirrel object detection, and in environment variables, I will have report values, it's Boolean, true, and then I have it's true, and I can't remember why I used the LEDs on the buzzer. I think I am changing the LEDs on the ReTerminal and the buzzer, and the container create options, the Docker configuration for this. So I will add this, review and create, And here I have my 4 modules running in the, I have my 4 modules running in the ReTerminal. If I go back to my ReTerminal here, to the list, I will see only 2. So, hey, these modules are kind of big because these modules, when you have this computer vision with TensorFlow, they are kind of use a lot of resources, but they are there. Because I know that it's going to take a couple of seconds to download a couple of minutes to download the module. Let me also show you this, how this is working in the device that we set up on Monday. So this is another Raspberry Pi that I have in my machine, my dev environment, and this one has running Squirrel OD. So this one, I can send an image to this endpoint, and it's going to do the object detection for the squirrels. So if I go back here, in example, to Visual Studio Code, and I open Thunder clients again, I can do a new request, something like, let's do a post and do HTTP RP dev 168080. I think it was 8080. Let's double check. No, not this one. Sorry. It's 80. Where is 8088? Sorry. 8088. And I will do image. And in the body, let's pick up an image, sample image for the, go for squirrels. So I am going to pick up, oh, not this one, sorry. I'm going to pick up a sample image. I'm going to send this, and this is going to perform all of the image analysis from the image. And let's take a look at this. So I am going to have a result here that this recognizes this as a space wolf. 98% sure this is space wolf. And I'm also going to have some coordinates, the top and left, and the width and the height, to basically draw a frame on the image. So I know that, hey, I recognize this image, this object, and it's here. And I can use this one. I can go to my imaging, to my first, the camera view that I have here, and for each frame that I am having in the ReTerminal, I can start to do this. So I have here one of the samples that I have. It's basically, let's open this one, the 3, and minimize this. So this sample is basically open a camera. The camera is here in the USB camera that we see on the ReTerminal, and is going to do an iteration for each one of the frames that we have, and it's going to show the frame. And if I press a button or the letter D, it's going to enable the detection. So it's going to call, in this case, the other Raspberry Pi, and is going to analyze this image. This is going to basically analyze the image and show the frame of the image there. And it's going to also save the image locally in the disk. So if I go back here, this is RP16. So let's take a look at ReTerminal. ReTerminal is, oh, we have everything also up and running. So we can do ReTerminal, we can do everything locally. This is my ReTerminal that has the drawings and the Squirrel OD, object detection, also running there. So what I am going to do, I am going to use this file, but I can say, hey, locally in the 8088, let's do the analysis. And let's run this to see how it works. So I have it here. Let's close this one. And let me go for custom vision, ReTerminal labs, 30, do it here, ls. So just to recap what I am going to show, this is a file, a Python file that is going to open the camera that we see here, the camera that we see here in the back. Let me change the layout so you can get a better look at this. So it's going to show the camera. This is the camera in front. When I press the letter D, oh, I don't know what I Oh, there is a toolbar here. There it is. When I press the letter D, it's going to start to do the object detection. So I am going to press the letter D, and you can take a look here that is running on the back and is detected the space wolf and the squirrel. And also, let's stop this. I press the letter D again. So let's stop this. And also, this sample is going to save in the local directory, is going to save all of the detected files that I have here. So if I detected I have the original file, which is this one, and the processed file, which is this one for this. So if you want, we can use both. We can have this up and running. And, hey, this is cool. Let's delete all of this. Let's remove one of the guys here. Let me remove the squirrel. I'm sorry, I didn't remove the squirrel. I removed the marine. But now I can go here, enable the detection again, and you see that it's going to do this in real time. And hey, if we want to see how this is working, if it's really working, I can even get here. Remember, I am here in the SSH of the device, and I can do something like clear, and I can do sudo IoT edge logs for the squirrel OD. And I think I need to do F. No. E. F. This is going to show me in real time the analysis that it's doing. So I can see here that this is an SSH going there of what we have. If I remove this and I add again this one, this one. So I have the Space Marine, and I enable again the object detection. This is going to show, oh my God, it's detected a lot of stuff, including a squirrel there. Why is doing this? Mostly because in order to test this, I add a very, very low threshold here. So when I am analyzing the image, and remember that I have results that include, I detected this object and they have the probability. So my probability right now it's at 10. I should upload this to, I should up this to, I don't know, let's do 35 and save. And if we start this again, you will see how this is working. So a couple of things here. There it is again. Let's delete all the detected files. Go back here, start the detection. You see how the SSH started to work, and hey, still have somehow a squirrel in the bottom. I don't know, this is not a good one. It should get something different. Add a squirrel there. And by the way, I am moving things around, and you see that the camera is not refreshing in real time because it has some delay. So we need to get back to work. But hey, this is when I start to stuff. Hey, now it's detecting the squirrel as a space wolf. Back to squirrel. That's better. I like that much better. It's switching back and forward. I don't know why it is doing that. Maybe I need to clean and I need to improve my device. But hey, this is kind of the idea. We have 5 more minutes to see if you have any questions. Right now, just to give you a sense, what we are seeing here is what is happening in the back, which is also what is happening in my TV right there. So full layout of demos. It's super tricky to give you a sense, but I hope that you like and you get an idea of what we can do. Let me go back to the slides and do a quick recap of what we did today. So we did a quick review of the SeedStudio, the ReTerminal. The ReTerminal is an amazing device. You can do this, again, you can also do this with the Raspberry Pi. The SeedStudio has the screen, has the USB, you can connect the camera, so they can do plenty of stuff there. So then I show how the ReTerminal is also an Azure IoT device. Basically, what we saw on Monday, this is something that we can use. And hey, create a custom vision module to do image recognition, to detect first drawing, now squirrels. Move this to be a module. Move this, basically merge this to create a module and a custom vision there, and then deploy it to the ReTerminal. And there it is. It's working there. As usual, this is the moment I am going to ask you to, if you have some moments, we already shared the link so you can complete the survey. This is the survey link and the string, and the event code. And also please join us and follow us on Twitter and YouTube. The videos are going to be all there. I'm going to close with this, but I will open this for questions because I have this one here and I have another demo that, let me show you the demo, which is using the buttons. Remember that the ReTerminal has button, has a buzzer, has more stuff. So here, if I open the number four, what I am going to do, I am going to check the buttons from the ReTerminal and I am going to interact with the button. And also when the press F1, the one of the button is going to do this, and also you're not going to hear it, but every detection is going to enable a buzzer, which is super annoying. But here, this is in super low also and detecting everything. This is not the best demo. It's somehow detecting every space wolf almost everywhere. I move it a little so it maybe detects better squirrel, and the sound, there it is, the squirrel, and the sound, the noise suppression is, I am going to stop this. It's removing this, but there is a beep, 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 a big buzzer code, a big buzzer noise in the back for every time that you detect something. Imagine that you want to use this in a security camera environment where you want to detect stuff. This is something that we can use and do something like this. And I don't know if you also see how every detection we have blinking LEDs there for this. Probably not too bright to take a look at this. So we are on time. It was a pleasure. On Friday, we are going to move this one level up where we are going to do this and use this as a digital twin, where we are going to use maybe a door or maybe an elevator, depending on the time that we have, to show how we can use a Raspberry Pi and the ReTerminal and create a digital twin with a physical device. So thanks a lot. Let me go back to our slides. See you in next one. And I hope that you are enjoying the JulyOT. Goodbye.